sooner, it's less pain. It's a lot less pain. And if you learn later, more pain. And I would prefer you not go through more pain. So, if you think that I'm nuts, or if you think that I don't get it, I suggest you talk to some of the people who are older that you admire most in the world. And oftentimes, a really good person to talk to is grandma and grandpa. A lot of times, grandma and grandpa really have their act together. They've been through so many different things, and they don't get over emotional. They got things under control, and there's no conflict or less conflict with them than there is with your parents. So I would suggest it. And lo and behold, all of a sudden you start doing the right thing because it's the right thing to do, and then all of a sudden all these really good things start happening in your life, and you get blessed beyond your wildest imaginations. So it's a win-win for everybody all the way around. So, all right, let's take a look at these particular questions. From the diagram below, A, what is the scale factor? And there is no diagram here, and I didn't draw one on your paper, so we can't do that one. So your math teacher screwed up. And I'm wont to do that way too often. All right, what is the image of the point? 3, -4 after a dilation by a scale factor of -3. Who knows it? Josh?
-9, 12.
That's right, -9, 12 is correct. What operation do you do whenever you do a dilation? Multiplication, good. So, 3 -4 times -3, I'm gonna multiply each of them by -3. That's -9, positive, that's a positive sign, 12, so -9, 12. What's the image of -2, 4 after a reflection in the x-axis and then the y-axis? I like to actually draw the point and use scrap here, 1, 2, 3, 4. So there's the point, -2, 4. Now, if I reflect in the x-axis, what are the 3 words I remember every time I do a reflection?
Repeat.
Count and repeat, right? Ready? 1, 2, 3, 4.
1, 2, 3,
1,
4.
2.
1, 2, 3, 4. So that would be the coordinate -2, -4. And it's worth noting here that when you reflect over the x-axis, the x guy stays the same, but what happens to the y guy?
Change.
Not only does it change, how does it change?
Goes
It becomes the,
opposite.
yeah, opposite or negative, okay? So what we could say is if we reflect over the x-axis of the point xy, you get, the x stays the same and the y becomes negative, so you get x negative y. All right, what if I reflected over the y-axis? Count and repeat, 1, 2, 1, 2. That would become +2, 4. And then look what happens. When you go over the y-axis, the y's stay the same, the 4 stay the same. The x's, however, got negated. It was -2 and it became +2. Okay? In the space below, graph the line y equals 1/4 x plus 3. Here's 3. 1/4 is up 1 over 4, up 1 over 4. There it is. Now, we talk about triangles here. See this triangle here?
Yeah.
This is 1, this is 4. By the way, the hypotenuse would work out to be the square root of 17, because 1 squared plus 4 squared, remember the Pythagorean theorem? But there's another one that's formed, another triangle right here. Oh, you're supposed to turn blue. This is 2, right, because this was 1, that became 2. This was 4, that guy becomes 8. So everything becomes twice as big. So the scale factor would be 2. Listen, do you need medical help?
No.
All right, then we need to calm down. You with me on that?
Yeah.
All right.
You bit me real weird.
I bit you?
Yeah.
I bit him.
Alex, look, I'm not blaming you, so let's be clear about that. But I have some just world advice for you. Never let a boy close enough that he can bite you.
I didn't bite him. I didn't bite him. I wouldn't put my mouth on any boy.
He took some.
Certainly hope not. Okay, now, let's go to the next part here. Today's lesson, all about rotations. So what we're going to do is rotate. And I kind of laugh every time I think about that because when I was a kid, we used different expressions than we use now. Like you guys, there were, going back over the years, Shania,
My day.
going back over the years, there's been a series of words that have become very popular with the kids. Like, for instance, many years ago, going back, oh, good Lord, at least 20 or 25 years, the common expression was all that. If a kid was like stuck up or conceited or arrogant, they'd look at it and go, man, that kid thinks they're all that. That became an expression. Then there was another one that came out,
Right.
Ite.
Right,
Yeah, it was short for all right. Ite.
We still use that.
Yeah, a little bit.
No,
But it's not as popular as it used to be. It used to be like all the time.
I.
Then my sons had one. My sons had one a few years ago. The first book there was two, I can think. One was a smack in the mouth. The minute they said it to an adult, I smacked them in the mouth. I never even thought twice. Wow.
Wow.
Wow. Wow. What it would be is something like this. Someone would look at them and say, I don't care if they said it to a kid, it's to an adult that they got smacked in the mouth. Wow was like, I am the ultimate authority on this. And you did what? So kids would walk around like if a teacher in the hall said, hey, come on, get to class. The kid would go like, wow. Wow. If my kid dared say wow, it was a crack right in the mouth.
Why?
Because if the kid is saying that the adult needs to live up to the kid's standards. And that is exactly the opposite of the way the world works. The kid lives up to the adult standard. So if my wife like looked at my kid and said, hey, go clean your room. And they looked at my wife and went, wow. Like if they were watching TV and they were like, wow, how can you interrupt my program so that you really want me to clean my room? The minute they would say that, right in the mouth, guaranteed, instant, automatic.
Deeply.
And then there was this other one that used to bug me to no end. For real.
For real?
For real, yeah.
For real?
Yeah.
People still use that.
I look at him, I know, right? My son would look at me and he would go, no, Dad, for real. And I go, no, for fake. What do you mean for real? Shouldn't it be that any word that, in the words of The Godfather, Marlon Brando in the movie The Godfather, if he leaves these lips, it's a promise. If I say something to you, it is the truth. I don't need to clarify that any further and say, for real, as if there's another alternative. If I speak it, I'm telling you the truth. I don't lie. So when my kid would look at me and go, no, Dad, for real, I go, what was all the other stuff you said? Was that like, maybe? Maybe not? I'm not supposed to, if you say it to me, it's supposed to be the real deal all the time.
That's what FR said.
For real?
Yeah.
It just makes me shake my head. So we had certain
SMH,
expressions when I was at home.
SMH. SMH.
Yeah, well, I told you what I thought that said. What I thought SMH stood for. I never told you that?
Oh yeah, I know.
So, no.
Wait, ask it.
When kids, I would read it on like Facebook.
Yeah.
I'd see people write SMH in the middle of their post, or at the end of their post, and I would turn around and go, what's that, shut my hole?
Oh.
What is SMH? And then finally, one day, a kid looked at me and goes, shaking my head. I was like, oh, okay, that makes sense. So, but going back further, one of my favorite expressions when I was young, I remember I told my sister this and she cried.
Right.
I really hurt her feelings. She got very upset with me. And it's like the only time she ever got upset with me in her whole life. I felt so bad.
What happened when you punched her?
No, that was a different sister.
Oh.
Different sister. Oh, that was constant problem. That was Sandy. That's the one I smacked. Carrie is the younger one, and Carrie and I always got along really, really well. So, except this one day, she said something so stupid to me. It was like the dumbest thing in the world. And the expression that we used to have when you said something, like if somebody did something stupid, is we would look at them and go, "What are you, dense?"
What?
Dense. Like you're thick, you can't get into your skull.
No, now it's yours, bud.
So, Sped was around when we were kids too.
Spade?
Yeah, we used to use that terminology. So,
Who also uses
anyway,
it?
So I looked at her once and said, "You're dense." And then there was this show on TV called Happy Days.
Oh.
I loved Happy Days. Happy Days is a great show.
It was a happy day back then.
Fonzie was on it. Remember Fonzie? Hey. And they had like the insult back in the 50s. Oh wow.
Rip chocolate. Wait, it landed on the.
I know it did, but I still won't take a chance.
What about the word rat?
I wouldn't-
So, no, what it used to be, he used to say, on that, they used to say, "Oh, go sit on it." That was like the big insult back in the 50s. Go sit on it. So,
Go sit on it?
yeah, but there was another one too.
Okay.
And it was like, you would look at your friend and you go, "Oh, go rotate." Now, I don't exactly understand what that meant, but that's what they would say. They'd say, "Go rotate." So every time we do rotations, I was like, could you imagine if when I was in school and all the kids said, "Go rotate," was like a really big insult? And the teacher stood up there and said, "Today, we're going to rotate." And you're like, "No, sorry, I'm not rotating anywhere anyhow anyway."
What
So,
does that mean, rotate?
Are you?
again, I don't know. I don't, I never understood where the expression came from, but they say it, so it is what it is. All right, so, here we go. You need to be able to recognize rotations and outside of coordinates, with no coordinates. So look, rotation means we spin things, okay? And let's be clear, on this first diagram, the rotation turns, notice the direction of the arrow here. Everybody see this? So you start here and you turn this way. And the first thing that's really important to notice is 90 degrees a positive number or a negative number? Hey, head the game. Positive number. So when I rotate in a positive direction, I go counterclockwise. Right, clockwise means the way the clock spins. Counterclockwise means against the way the clock spins.
Opposite?
All right, so when we have a positive rotation, we go the opposite of the way the clock spins, okay? If you notice, this point here becomes this point here. This one here becomes this one here. And we would say that the black triangle, when you rotate it 90 degrees, it becomes the red triangle. And the way I write rotate 90 degrees is like this. R sub 90. Big capital R, very important, it's a capital R. Little r is a reflection. Okay, capital R, 90 degrees. Now you can look over here and you can see another rotation. It's a positive rotation. How do I know that's a positive rotation? Because it's going counterclockwise, and it takes the pale triangle and rotates it to become the darker triangle. Okay, any questions? All right, so far, you should know that if you rotate in a positive direction, you rotate counterclockwise, and you should also understand how to recognize a rotation. All right, so here's a little summary. Clockwise means you go this way with the hands of the clock going. Counterclockwise, you go backwards. And this is a quarter turn, which is 90 degrees. Another quarter turn makes a half turn, which is 180 degrees. 3/4 turns again, and that's 270 degrees. This is actually negative 90, 180, or negative 180, and then negative 270. Negative because any clockwise turn is a negative rotation, okay? And you rotate it, okay? All right, so you know from your work with figures that we've done already that you always start with P, Q, R, and you always become the ones with the little hash marks. We call it prime. So it's P prime, Q prime, R prime. So you start with the regular letters, you become the prime letters. Is this a positive or a negative rotation?
Negative.
What do you got here? Positive or negative rotation?
Negative.
Let's see, show of hands, because I'm hearing both. How many say it's a positive rotation? How many say it's a negative rotation? It is negative.
Yay.
Positive always goes counterclockwise. This is going clockwise. P, P prime, R, R prime, Q, Q prime. Okay? Now, we need to learn how to rotate. Turn the page.
That's how you rotate.
So what I would like you guys to do, everybody on your paper, mark the point 3-7. Just make a dot, a nice big noticeable dot
3-7.
on the point 3-7, yes. 3.37. There it is. Everybody see it?
Yes.
Okay. Now I need to teach you how to rotate 90 degrees on your paper. Now, there are some ways where you can memorize formulas, but the best way I know of to rotate 90 degrees, you didn't mark your paper. Come on, head in the game, mark your paper. I need to show the whole class your paper. Make it nice and big.
I got it.
Yes, yours.
Why am I?
Just do it. 3-7.
I got it. Well, I mean, I have a pencil.
Oh,
That's fine.
3-7, make a dot.
Wow.
You shouldn't
Good.
take it after there.
Now, here's what we're gonna do. Yeah, we're not down south. Okay. Here is the paper. Now what we're going to do is a 90-degree rotation. First off, is 90 positive or negative? Positive. So which way am I going to go? It is to the left, but we use a different terminology.
Counterclockwise.
Counterclockwise. Everybody take your paper, put your finger right in the middle of the axis, and turn your paper 90 degrees. That's a quarter turn.
Wow.
Now, what would the new coordinates be? If this was just, if you just plotted this point, what would those coordinates be?
7-3.
Not 7-3.
Negative.
Negative 7-3. So the answer to 3-7 is negative 7-3. Now, what I would do, you just take your paper, you turn it 90 degrees, it would spin. That's what we did on your paper. Here it is, we spin, bing. Now, what would the new coordinates be?
Would it be 3? -7?
No, it would be negative 7-3. So what you end up doing is switching them, and then you negate the first one. Now on your paper, I want everybody to mark negative 2, 4. Negative 2, 4. Now, turn your paper 90 degrees and tell me what we call it the image. What is the image after a rotation of 90 degrees? Okay, what do we get?
-4, -2.
You agree with that?
Yeah.
Negative 4, negative 2. Do we all agree? Okay, so excellent. I do agree. Let me just, I want to change colors here for a second. Here was negative 2, 4. We spun it 90 degrees and we came out with negative 4, negative 2. Now let's do the last point, negative 1, negative 5. Now spin that 90 degrees. Matt, what do you get on that one?
I got 5, -1.
Ava, do you agree or disagree?
Agree.
Agree as well, I also
Oh, for
agree.
the first one.
So this becomes 5, -1. Now let's look for the pattern. Do you see how every single time what was in the X place went to the end? And what was in the Y place went to the beginning, and it did one other thing. What did it do? Changed its sign, right? So in general, if we wanted to, we could say, if we rotate 90 degrees, any point X, Y, the first guy always went to the end, so the X goes to the end. And what happens to the Y?
It goes in the front.
It goes to the front and
Indicate.
in negate.
Or it changes the sign.
Changes the sign. Negate is the word for changes the sign.
Oh, I thought it was
Okay, now, let's, those 3 points are already marked on your paper, and it's a good thing, because now we're going to do 180-degree turns. So take the same 3 points and rotate them 180 degrees. Go ahead.
Ow.
And then write down the answers each time. No, 180 is twice.
Oh, oops.
Yeah, 270 is 3.
Should have asked.
Yeah, you do end up with your paper upside down. So rotate 180 degrees, and then go back and write the coordinates in for each one of those.
So. Pick up that. So it's 90. 100 cost, what is it? Wow.
Okay. When you took the point 3,7 and rotated it 180 degrees, what did you get as your answer? -3, -7, I agree. When you took the point -2, 4, and you rotated it 180 degrees, what did you get? Ava?
-4, -2. I mean -4 too.
No.
What?
Joe? I'm sorry, Joe, I didn't hear. I think it's gonna be, 2 -4,
Oh, I did
right?
that wrong.
Check your pad, I think it's 2 -4, everybody get that? So now look at the pattern, let's guess on what you think the third one would be, looking at the pattern. 3 became -3, 7 became, -2 became, 4 became, so what do you think we're gonna get?
Positive 1, positive 1.
+1, +5, and is that what you got when you spun your paper 180?
Yeah.
Nice, okay, this time we're gonna spin it 270, so how many quarter turns is 270?
3.
3/4 turns, good, fill in those 3 values for that one. You could go, watch me now, ready, everybody look, watch, hey, don't look away. I could go 1, 2, 3, or I could just go 1 the other way, right?
Yeah.
Doesn't that work?
Yeah.
So -90 is the same exact thing as 270.
So it's the same answers? What?
No, because it would be negative.
What?
No whistling. Hey, you didn't write any of your answers down. Right? At some point, you're gonna wanna refer to this, I hope, and use it to help guide you. And having those answers down is a beautiful thing, beautiful way to help guide you. Okay, so, what does 3,7 become, guys?
-3 over -7?
I think you actually come up with -7.3. Let me see if that's
No,
right.
it's negative, it's, yeah,
They're both
It's-
negative.
Yeah, they're both negative.
no,
that's
it's
Hold on.
7, -3.
Hold
Yeah,
it.
that's not-
Here's 3,7. Ready? I'm gonna go 1 this way. It's the same as 3 the other way. 7, -3. That's right. What did I have? Oh, I had it backwards. +7, -3. Okay, what would the next one be?
4, 2,
That would be 4, 2. Good. And the last one?
5, 1.
Isn't it 5, -1?
Oh, it is.
Yeah.
Right? Isn't it 5, -1? Turn your paper, guys. Make sure it looks like 5, -1. Are we good?
Oh, yeah.
Okay, so today we covered rotations. I know it's been a few days since we've done things. Last week we covered reflections. Tomorrow we start our work on translations. We'll do a little more when we get back. And then after we get back, after we do reflections, rotations, and dilations, we then get into some vertical angles and stuff, and then we finish up geometry.
I don't even know.
Yeah, this stuff is easy.
Huh?
You got something?
What are these?
What?